For our next example of a ring, we're going to come up with a set that we haven't worked with before. So it's unfamiliar right now, but we'll get very familiar with it throughout the semester. So we're going to give it another name later on, but for now I'm just going to call it S. And S is going to be the set of all numbers of the form a plus b root 2, where a and b are rational numbers. So I can take any two rational numbers I want and put them together in this way, a plus b root 2. So S is a subset of the real numbers, right? Every number in S is a real number, but there are lots of real numbers that aren't in S. So S is a subset of the reals. So now I want to look through those properties of a ring and think through whether they all hold for S. And the first thing we need to do is think about the very beginning, addition and multiplication. We're supposed to have these two binary operations, but our big question here is S even closed under these binary operations, addition and multiplication? So we need to know if I add two things from S, I get something back from S. And if I multiply two things in S, I get something back that's in S. So I want to check that. I'm going to say let A and B and C and D be rational numbers. Okay. So then if I add two generic elements from S, so A plus B root 2 and C plus D root 2, what happens? Do I get something that's still in S? So I know these are real numbers. I know how to add them. And I might want to just write this down in the first place as this is just A plus B root 2 plus C plus D root 2. And then I might want to start doing sort of a combining like terms. So A and C, those are fine. I know how to add those. They're just rational numbers. And then I have these B root 2 and D root 2, which I know I can combine by saying it's b plus d times root 2. And the good thing about doing that is a plus c, that's a rational number. And b plus d, because b and d are rational numbers, b plus d is a rational number. And so this is now rational number plus rational number times root 2, which means that it's in S. So the sum a plus b root 2 plus c plus d root 2, it turned out it was in S because we could still write it as some rational plus our rational times root 2. So now we want to do the same thing with multiplication. So now I want to take a plus b root 2 times c plus d root 2. All right, so this is a foiling problem. If I do the first two terms together, that's an AC. The outer two are A, D root 2. The inner is BC root 2. And then the last is a BD times root 2 times root 2. So let's clean this up a little bit. I have AC, I know this idea of combining like terms might be useful, so I'm going to do that here with AD plus BC times root 2. And then that B times D times square root of 2 squared, that's just a 2BD. So I can combine like terms even more here. I have AC plus 2BD, and then I have AD plus BC root 2. And like before, what I'm worrying about is this in S? And so now I'm going to go through and say, well, yeah, I mean, AC plus 2BD, A and B and C and D are all rational numbers, and so that's just a rational number also. And AD plus BC is also a rational number. And so like we saw with addition, I was able to do this product and get a rational number plus a rational number times root 2. And so this product is in S. Okay, so S is closed. I'm going to write a little 3 dots like this means therefore. So therefore S is closed under addition and multiplication. Okay? So now, the rest of the properties of a ring, I'm going to go up and look at them. Because we knew that S was a subset of R, the rest of these properties are going to be fine. If I think about all the things in S as just real numbers, then yeah, I'm certainly associative for addition and for multiplication. I know that there's a 0, and we'll talk about that in 1 second. So let's save that one for a minute. And then for an A, there's a minus A. Let's write down what that is. So if I have an A plus B root 2, and I want the additive inverse of it, it's a minus A minus B root 2. And that gives me 0. And by 0, what we mean is 0 plus 0 root 2. I know that addition is commutative. I know that I can distribute because they're just real numbers. And here with 1, like up above, I'm thinking about 1 as just 1 plus 0 root 2, which is definitely in S, just like this one was, because 1 and 0 are rational numbers. And so the rest of the ring properties hold. So S, a ring, because it's a subset of R with closure under addition and multiplication, and 0 is in S, 1 is in S, additive inverses are in S. Okay, and then the rest of the properties just held because it was just real numbers adding and multiplying. So we will see some more results like this later on, where we can kind of exploit the fact that we're just talking about real numbers to skip a lot of the ring property checks.